Ooh, that's too big. And then notepad here. Mobile. Need to go. Okay. Hello, everybody. Hello. Happy Monday. Apologies, I just want to kind of cover this thing about makefiles because it's in your assignment. I'm sure some of you looked at the assignment. We'll talk about it just a little bit today. I know there's a due date set up there. And like I said, I'll just talk a little bit about that in a moment when we're going over the assignment. Because there's a few things we need to go over. Quite a few things. And I know I keep saying it, but these 2 Mondays that we had off really messed me up. But it's not terrible. We're just like a week behind the other classes. But as we get later into the semester, there are a few subjects that we don't need to spend too much time on. So I plan to play catch up then. So I'm just ranting to you guys. You guys have nothing to worry about. Sometimes I just need to think out loud. So, we're going to go ahead and just start talking about the assignment. Today I'm just going to run it for you. I did look at it. This was made by Dr. James Andro Vasco, or Jimmy. I highly recommend him as a professor, by the way. So if you happen to take CS 302 or any other classes that he might be teaching, 302 is the main one. If you can get Dr. Andrew Vasco, I'd highly recommend it. And he was responsible for making this assignment. Now, he's pretty comical. He gave you a light theme and a dark theme, just like every other app and website and software is doing nowadays. So if we come to our web campus here and you look in the assignments, you'll see assignment 4 is there. And it took me a while to put up the assignment. Not the files, but the actual due date for that. But you can see here you have this PDF, which is light theme and dark theme. It doesn't matter which one you pick. I'm going with the light theme today, but I do prefer the dark themes. I just kind of think it's better for streaming. Actually, for people who type questions in the chat, I notice, first off, I need to make that text bigger, but I also would like to use the black background because then the questions show up better on stream. So let me do that instead. So I'm sure some of you guys have played Mastermind before. I actually have a version of this board game in my house. And it's just kind of a guessing game. And so I'll briefly explain it. Do you see here, underneath this kind of shield, you can see that there's a combination of colors, blue, green, black, and red. And so this combination of colors was thought up by somebody. There's two people who play this game. There's the guesser, and then there's the person who's not guessing. So the person who's not guessing comes up with a combination like this, blue, green, black, red. And then the person who is guessing will put in color combinations to try to guess which one it is. Now, every time someone guesses, they get some white pegs or some black pegs. A white peg means that you got the right color, but the peg is not in the right spot. So as you can see here, it looks like kind of up here, this person guessed a blue and a green, right? And then they also guessed a yellow and a white. And if you look at this combo, you can see there's a blue and a green in here. So this person gets two white pegs because the blue and the green are correct, but they're not in the right spot. In the next guess, they put blue, yellow, red, black. So there's a red and a black in here. Notice that they are not in the right spot, so they get two white pegs. And then notice that the blue is in the right spot, so they get a black peg. So the black peg indicates that this person has guessed right exactly in the same spot, and then these two white pegs just mean that there's two pegs that are of the right color, but not in the right spot. And so they guess and guess and guess and guess, and then finally, at the very end here, if they get it before they reach the number of turns, they win. And so all you're doing is coding this game in C++. And the majority of the coding is just what you already know, kind of, with vectors. You should use a lot of vectors in this assignment. But really, you're just kind of implementing these things. The PDF does a very good job of describing it. And so I'm not going to go over it too much, but you do have this class, which is the Mastermind game. And so you have some constructors here. And then you have a few functions, which is you make a move. You get a move index, that's a getter, and you get number of columns, that's also a getter. It's a getter. And then you have a few private member variables. Max moves would describe how many rows the user gets. Do they get 5 guesses? Do they get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 guesses? So max moves describes that. Int moves keeps track of how many moves have been made already. So in this case of this board, there would be 10 max moves, and the guesser has made 6 guesses, right? So 6 moves out of 10 max moves. And then lastly, here we have the vector string. Remember that a vector is just an array, right? So this is the solution. So in this case, this array, this vector of strings would contain 4 strings, and it would contain the string blue, the string green, the string black, and the string red. So that should all make sense. So that's your class for the game. And then look, he just tells you exactly what they're for and how you should implement them. And then there's main, in which here we're doing the pointer stuff. Notice here we've got a pointer to the current game and a pointer to a saved game. And so this is where we'll be practicing what we learned last week with using new and delete, and also kind of flipping between pointers so we can really understand how we're supposed to use addresses. And so in main, there's also a bunch of functions that you need to implement. Now, I did kind of put in some comments. My comments were not super helpful for this one, but only because I'm just going to make sure that I don't mess anything up here. That's only because the PDF does a really good job of explaining what you're supposed to do. Right, so here we are in main. So you notice here that, I'll zoom out just a little bit. The main is kind of provided for you, as well as this yes or no thing. And what does this do? This function will just ask the user to input a Y or an N, and it returns true or false based off of that. You can see, though, I included this year code here, and in some of them I gave you some extra hints. But otherwise, I just say the PDF does a good job of explaining, and then I tell you that you're either going to be using delete or you might be using new. Here I say you'll use new, and here I'll say you'll probably use delete. And so that's it. So you got 4 functions in main, and then you've got all of the mastermind members to implement, which will be just these 3 things. So that's these 5 things, including the constructor. So you've got 7 functions and 2 constructors to implement. So yeah, like I said, I didn't make this assignment. I do have it due right now. Let's see when that is. I know some of you have started. Do you guys have any concerns? Because next week we have an exam, so we're not going to be assigning homework, or we'll be giving like an extra week to do whatever homework is assigned. Because next week is an exam. And next week on Monday, we're doing a review, so we're not going to learn anything new on Monday. And on Wednesday, you'll take the exam, and it will only cover up to what we cover today and on Wednesday. And I will give you a review sheet, so just you don't have to worry about that now. Just be on the lookout for it. I'll mention it. And then on Monday, I will like go through that review sheet and answer everything. So for those of you who've looked at the assignment, do you guys have any concerns? I'm going to check what the due date is now, and I'm saying that I may extend it, okay? So I just want you guys, I don't necessarily want to do that, but I might have to. So it looks like I have it due in 2 days. I'm guessing not very many of you have looked at it. So for now, let's say that I'll move it to Friday. But please look at it and get started and ask questions. Okay, so maybe I'll edit that now just so I don't forget. And then we're going to get started with the class today. It really is difficult this semester. I love having the Tuesday, Thursday classes. But yeah, I totally understand. So we're going to put this on Friday. That's when it will be due. And you'll have a late deadline until Saturday night. Okay. So it gives you quite a few days. It has been up, right? But we did just look at it. I'll give you a quick little run of the program, and then we're going to get started today on our class. So as you can see, I moved it here. It's available until the 27th, but it's due on the 26th. So that's been adjusted. No problem. And as long as you talk to me, you know, I'm not trying to like murder you guys or anything. I want you to pass this class. And so just talk to me. That's all I ask. So, like I said, I'm just going to run this program here. So I'll show you what's going on. In the notes here, you'll say that I talk about this makefile thing. And this is how you'll compile this assignment. And so we're not going to go over makefiles today. I'm just going to show you how it works and that it's nothing scary. Makefiles are used in Linux systems. So the first thing you have to do is make a file, like a text document, and you're going to name it makefile with no extension. It's just going to be makefile. And inside that file, you're going to type out your compile statement. For example, what we've done all year is g++, std equals c++11, main.cpp-g. And then when you're ready to compile, instead of having to type out this statement, you can just type make, and it will do everything for you. So I'll just show you what Dr. Andro Vasco put in his makefile. And it's a little more complicated than you have seen before, so we're not going to spend a lot of time on it. But you can kind of see here that we've got a G++, and then he's specifying some different files here. But you see he does another G++, he does another G++, and then he does some more Linux commands. And so all this is the compile statement. You can see that VS Code knows this is a makefile because it's got this M here. And you don't have to do anything in here. Just when you're ready to run the program, you come in here, you got to put all 4 of your files in here, right? Which is mastermind.cpp, mastermind.h, main.cpp, and the makefile. You'll just type make. And I need to go into the directory before I do that. You just type make. And you can see here that it's doing its thinking. When it's done, you can hit ls, and you'll see that he changed the name. Instead of a.out, it's going to be game. So now that it's compiled, I can just say /game. And we're now playing Mastermind. And so here's the main menu. If you downloaded early, this might be vertical or horizontal rather, where it says like play, and then the load is next to the play, and then the continue is next to that. That's okay. I will not mark you for that since main was provided for you. I just made this small update later on. So we have this menu. So if I type P, I'm going to play a new game. If I type load, I'll try to load an existing game. If I type C, I'm going to continue a currently saved game, or Q to quit the program. So if I type L right now, it's going to say, hey, there's no game to load, which makes sense because we haven't started yet. So it's going to say, hey, there's no game to load, which just means that the saved game pointer is null, right? The saved game pointer will be empty, so I cannot load anything. If I hit continue current game, I'll type C, and it says, hey, no current game found. Why is that? Well, that's because we haven't started a current game yet, and the current game pointer is empty. So the moment we press play, we'll type P, and it asks you to enter the peg colors. It can be as wide as you like. So we can do 5, we can do 3, so we'll just do 3 for now. So I'll type red, blue, and notice that it will be case insensitive, right? So whatever I do here, it's case insensitive. Red, blue, green. I'll hit enter, and then I have to type a 0 to let them know that I am done typing in colors. And notice that it figured out that there's only 3 colors, and now it's for someone's turn to guess. And so let's say the person who's guessing will say green, red, and then yellow. Notice here it says Gold peg 0. Gold pegs are the black ones, which means I didn't get any of them exactly right, but it says I've got some silver pegs here. Those are the white ones. I don't know why they're gold and silver in this case, but notice I have 2 silver pegs, right? Because I guessed a green and a red, and notice that there's a red and a green in here. And so I can continue on with this. Before I do that, if I hit pause, say, okay, we all need a break sometimes, and it says, would you like to save the game? So you can hit yes or no. If we type yes, it'll save the game, which means it puts the current game into the saved game pointer. So now if I type C to continue current game, it's going to say, hey, there's no current game because you saved the other game, right? So in order to extract the saved game, we have to load it. And so no, I can't do that, but I can load a game. And notice that it loads right out of the saved game. So I can continue from there. I can pause. It will ask me if I want to save it. I can say no, which means that if I try to load a game now, there's nothing that's saved. So we'll say no game to load, except there's a bug here. I didn't code this solution. So really, if you just follow the PDF, you kind of get the general gist, right? Even though I've found a bug and I really wish that there wasn't a bug in here. You're kind of just going to be playing games. You can quit, you can pause, and then you'll just save games in the saved pointers or the current game pointers. And that's really it. I guess I'll just show you what it looks like when we win. So let's just say I do 2, red, yellow. If I type red, yellow, you'll notice that I won. The game is destroyed. And that's that. There is plenty of sample output for you. There's one bug. There's one thing here. Notice that here, right off the bat, there's 5 colors. But then it only tells you that's 4. That was an issue with Dr. Andrew Vasco's computer. Just pretend like we only entered red, blue, green, and orange. But everything else in the sample output is fine. So you can just follow the sample output to compare, and everything will be good. And that's that. Ask questions, please. Don't get stuck. Don't get scared. Let's get through this together. And it won't be too bad. So I'm gonna quit this game, and we're gonna move on because we really need to do that. Just let me know in the chat if you have any questions immediately about that assignment. So now we're gonna get into the fun stuff today, which is more pointer stuff. So if we're looking at our syllabus, like I said, we're a little bit behind, but we're kind of here on the memory allocation and management side. So this week, but notice that we're a week late. So in fact, we're on week 6. So memory allocation and management should be here, but we're not going to move the midterm. We're going to keep the midterm next week. Sibe asked, will we be using the arrow in assignment 4? Yes, you can. And today I will cover the arrow. You can, but you don't have to, because I showed you last class how to do, how to get members out of an object pointer, right? But I'll show you today what the arrow does. It does exactly the same thing. And we're also going to look at this, the keyword THIS. And so I guess the first thing we'll do is a quick refresher on what we talked about last week. We're not going to go over everything we did. I'm going to kind of skip forward here. All these notes are uploaded on Web Campus, of course. And this was all what we talked about on Monday. And then last week we talked about pointers and dynamic memory. So how do segfaults happen? We dereference a null pointer. Pointers, they hold an address. Pointers have types. We know this. We use pointers for dynamic memory allocation, which means we're going to allocate memory during runtime. How do we do this? We use the new keyword and we use the delete keyword. We're going to be using those today again. So just look for those. And then we talked about the 3 dangerous things here. We talked about what memory leaks are. We talked about what dangling pointers are. And we talked about what aliasing is. And this is what's dangerous about pointers. And we'll be talking more about that today. I showed you guys how to run valgrind. You should run valgrind with assignment 4. And then this is the last bit here, right? I said how to access member functions within object pointers. So if we have some class, right? Remember this. Let's say we have some class A. And then we make a pointer object for that. So I called this object pointer equals, let's say, new A. Right? Because we have a class A, and I allocate memory and call a constructor. And then in order to access the member within that object, I need to first dereference the pointer, and then I need to use the dot operator on it. And this is exactly what the arrow does. So today, I guess we'll go ahead and, well, we won't start with it, but I will just let you know, and I'll put it later here in the notes. This works just as well. So notice here that the arrow looks much nicer and much simpler than whatever this dereference dot thing is. And they do exactly the same thing. And so we're going to go over that today. So that's what we talked about last class. And those notes are uploaded on Web Campus. Oh, I guess today the first thing we do cover is the arrow. No worries. So today we're going to learn 3 operators. Let's just start by putting out our operators before we get into our example. So we'll start by coding our operators here. I just showed you what the arrow is. And so we'll type that out. Here's our arrow operator. What is that? That is the same as, let me get some enters here. We're going to say that's the same as doing a dereference operation on an object pointer and then calling the dot operator here. And so what does that mean, right? In other words, i.e., it dereferences the pointer. And uses dot operator. And so I did just give you an example of that. I'm just going to copy paste this example here so you guys have it, and we'll just talk about it a little bit. Assuming we have, say, this class student. Notice it only has one member function, the string, or one member variable, which is this string name. Looks like we might be having a bit of a laggy connection. It's about noon. That seems to happen sometimes. So I'm just going to give it a moment. To come back to life here. Are we alive in the stream, folks? I got an unstable connection right now. It will fix itself in just a moment. It should at least. It looks like it did fix. So you guys should all be able to hear me right now. Hopefully. Yeah, it looks like I'm moving. So I'm going to continue on. So we have some class student with just some member variable. And then with this in main, we'll have to declare some pointer. And then we're going to allocate a new student into that pointer, right? And so I can either put something in that name by using this arrow operator, but they are exactly the same. So I can either dereference dot, or I can just use this nice arrow, which makes things much nicer. So that's our first operator for the day. Excuse me. Now we're going to talk about new. Now we already talked about new, right? But today we're talking about new in a different sense. Because last week we talked about just single variables, right? Where we have a pointer that's pointing to one object. But what about arrays? Today we're talking about arrays. So this new is a little bit different, in which we'll say it's the same as new from last class. But here is for arrays. And so all we have to do for that is say we have some type. It's a pointer, so we got to make sure that we've got that star there. And whenever we're ready to allocate it, we will say new type. And then we're going to add these brackets here to let everyone know that we're doing an array. So we're going to do an example of this in the code. And in here, we're going to have some int x. And so what does this do? Allocates an array of size x. So notice that new is actually not used any differently than we did last time. It's exactly the same, except you just have to remember to include these brackets on the end. And the brackets will tell the compiler that we want an array. So here I have an example. If we're doing an integer array, we're just going to say new int 10, which creates an array of size 10. That should make sense. And then lastly, we're going to talk about delete. Now this delete is different than the last delete. Notice here we've got some brackets. So this one is same as delete from last class, but for arrays. And so here's what this operator does. Only if it has the brackets, okay? So recall here that we're now just talking about brackets. Only if it has the brackets will it do this. It will check the pointer to see if it is either null pointer or null. If it is not null pointer or null, deallocates the whole array. So wider. Okay. Now, this is something that will get you guys. You need to include the brackets to tell the compiler that this is an array. If you forget the brackets, it will just deallocate the memory in the first array location, right? Hopefully that makes sense. If we've got an array of size, what do I got here? Size 5. If I use delete here, it will only delete this first one. And then we've got a memory leak on these 4 elements. The moment that we add the brackets here, it will delete all 5 of these elements. So here's an example of that. Pretty straightforward. Okay, we did our allocation of an array, and then when we're ready to delete it, probably not exactly like this, right? We're going to have some code in between. But at the very end, we're going to call delete on this pointer to delete the entire array. So let's just go ahead and write a small program to show you how these things work, to show you that it compiles. And then we're going to move on here into some further stuff. So here I have just a regular C++ file. We're not doing any header files here. Maybe I'll make a make file just for fun. But in here, the first thing that we need to do is let's assume that we want a dynamic array. And the dynamic array, can anyone tell me from last class what advantage a dynamic array has over a static array? What the main advantage is? Or at least what you think it is. I guess we'll just call this an array. And let's go ahead and set it equal to null pointer. So first initialize it. And then I'm going to say something like cout. Yes, exactly. Both T. Peter here and Sibe nailed it on the head. Dynamic arrays, we can change the size, okay? It's dynamic, so we can add elements, we can delete elements, so that's exactly the advantage of using dynamic memory allocation. So in this case, notice I've got this nice array pointer here. It's just for ints, and I'm saying, hey, what size would you like this array to be? And so now I can go ahead and see in some size. And then the next thing that I want to do is I would like to maybe check to make sure that size is greater than or equal to 0. I'm sure some of you will have this question, so it's good to include this. So you can allocate an array of size 0. I guess I'll put that in the notes. Almost never will you do that, but it helps the code be more streamlined. So I'll just put this as a side note. You can allocate an array of size 0. So that's very possible. I know it doesn't make much sense, but like I said, it will help our code be more streamlined. We don't have to deal with that case necessarily because it's already built into the new and delete already. So if our size is greater than or equal to 0, then we can go ahead and say array is now equal to a new int of size, right? In which I'll call this allocation for an array. Else, let's say cout invalid array size. Something like that. And then let's go ahead and just put in some elements to show you that this array is going to store some things. So I'm going to say cout enter your elements. And then for int I equals 0, I is less than our size, I plus plus. I can do one of two things here, right? I can say this. This is probably the easiest one. Right, so I'll just see in directly to the array. Remember that this is an address, and the bracket dereferences it. Notice that this would be the same as saying array plus I dereferenced. Remember that? I think you guys do, or hopefully you do. These are the same. Because we're dealing with a pointer here, right? So in this case, we'll just see in here because this makes more sense to us. We'll put it in, and then we're going to make a nice print array function just to see that everything looks good. And what we'll pass is the size, and we'll pass the array. Now, I don't want any memory leaks. So at the very end of this function, I'm going to call delete on array. Now I'm going to see if you guys have been paying attention. So notice here up top, I assign null pointer to begin. Now let's say I allocate, or I say, hey, I want an array of size -1. And so this if statement will be skipped. And here it will say invalid array size. And then down here at the bottom, I'll call delete on a null pointer. Is there any problems with that? In the meantime, while you're doing that, I'm going to type out my print array function. And remember, you can always pass pointers as parameters. But this is almost like passing by reference. So if we want to put that in a note, passing a pointer now you could do this, but now we're just getting kind of confused because we're actually passing the location of the address. And in this case, we're passing a copy of the address. But in both cases, we're passing an address. So it's passed by reference. So we may have a delay here, but if we look in our notes, I'm just going to show you. The first thing that this delete statement does is it checks to see if the pointer is null pointer or null. And if it's not, then it deallocates the whole array. Else does nothing. So this will be okay. We'll be fine. Even if this array is null pointer, it'll be okay. Now this is different if we're not working with arrays. And you have to remember this specifically. You might want to make a note, or you might just want to store it in your head somewhere, that delete, maybe I'll even make a note down here. Delete null pointer causes runtime errors. But delete with brackets null pointer is totally fine. Is that confusing? Perhaps. But notice that if we allocate an array of size 0, we'll probably be deleting a null pointer at the end. So just remember this. And maybe I'll just do the dashes here. So that's fine, even if it's null pointer. Now I'm going to do this print array. So we've got some magical string here, which is equal to this. And then for int I, I'm just going to copy this for loop because I hate typing. And I'm going to say p plus equals toString array located at I. And then in this for loop, I'll do just a small check for fun. I'm going to say if I is less than size minus 1, then we'll add a comma. This is not necessarily important for you guys to pay attention to, but if it's the last element, I don't want to add a comma. And then at the very end, I'll say this string plus equals, another bracket, and then we're just going to see out p. Okay, so this is a small print array function. We're not going to spend time too much going over it. All I do is make a string with all of the elements in the print array. So we're going to run this code. Super involved and exciting example, I know. You can compliment me later. Our next example will be a lot more fun. And definitely you'll want to pay attention to that one. Because we'll be coding basically our own vector class. And I'll show you exactly how vectors work. So I loaded this. If I just wanted to make a makefile, anyway, let's do that. To show you that you can do it. I shouldn't have done that. Yeah, whatever. So all I'm going to type here is my g++-std equals c++ 11. SG equals C plus, I think I got that right. And then we're going to type in arrays.cpp. That's what this function, that's what this file is called. And we're going to go ahead and save it as makefile. I think this is the right day, right? So this is just going to be makefile. It should not have any extensions. Why is it not valid? All right. Apparently, Windows does not like that. So what I'll do is I'll load makefile.txt into Linux, and then I will rename it so we take off the .txt on the end. So now I have the makefile there in Linux. I'll just type make. And it seems that I made a small error. And let's see here what I should do. Looks like I need to add some headers, and I just want to create the simplest makefile that I can. But here I've caught myself off guard, and my knowledge on makefiles seems to be lacking. So we won't go over that. Sorry to seem stupid there. So let's just do our regular G++ statement. And sometime I will go over makefiles. So we've compiled our array here. We can ask what we would like our size to be. In this case, I can type, say, 5. In which case I will have allocated my array, right? So I've allocated 5 elements there. And then I can enter all of them. And then I enter all of them. It prints them in my nice little function. And then I deallocate it at the end. I can enter an array of size 0. Notice that this does nothing. I can also enter an array of size 1, which is basically just a regular element, right? So you may wish to save this code and reference it if you would just like to see a very simple example of how we can make dynamic arrays. And now we're going to move on into some more substantial material for this C++ tutorial on dynamic memory allocation. So what we're going to do today is we're going to make a dynamic array class. Just like vectors. You're going to want to save this code for the rest of the semester. So I'm going to upload this to Web Campus, and like I said, once again, you're going to want to save this code because it has pretty much everything in it that you're going to need when it comes to using classes and pointers. So imagine this. I'm going to be making a vector class. In this case, it's just going to be a dynamic array class. And its only job is to hold elements in an array like this. Just like we did in this main code here. So let's just assume that it's an int for now. Later in the semester, we'll learn about template types. But for now, it's just an int. And so we're going to need an int pointer for the array. And we're going to need an int size. That's all we'll need for this class. I want these to be private because I don't want anything to be messing with these variables. Now in our public, we're going to do just a regular constructor here. This is the default. Now I'm going to add in this kind of constructor. We'll call it an array constructor. And this one will take in an int size, and it will take in a pointer to an already created array. So we'll kind of create a dynamic array by already supplying the array and its size. And now we're going to talk about something regarding the rule of 3. We're going to type this in our notes. So the rule of 3, I'll tell you how we use it. Now, when do you need to remember the rule of 3? So when defining classes that use dynamic memory allocation, i.e. contains pointers. All right, so do we need to remember the rule of 3 for this one? Yes, we do, because it contains a pointer. So we could even put it here, rule of 3. Now, we'll ask this kind of thing on a test. What is the rule of 3? Rule of 3. So what does that mean? Classes that use pointers should have 3 components. Always. Component number 1 is a destructor. Component number 2 is a copy constructor. And component number 3 is an assignment operator overload. We will not talk about the overload until operator overload. So already for now, you don't even have to think about this number 3 thing, but we will go over these 2 things. And so if we do not include these 3 components, we will have memory problems. What are our memory problems? Memory leaks, aliasing, and dangling pointers. These are all dangerous when it comes to using pointers. And if we do not include these 3 components, our class is unsafe. And it's susceptible to these kind of things. So we're just going to I'm going to put some ideas in your head here. So the copy constructor looks like this. You guys know when the destructor is called. But what does a copy constructor look like? Well, here's an example of that being called. Assume we have a class A. And in this code, we've got an object called aObject1. And it's going to be just like that is fine. Now remember that class A contains a pointer. And so we're not going to be making object1 a pointer. And so then I make another object, object2, and I'm going to call a constructor that takes object1 as a parameter. And so the copy constructor will build object2 exactly like object1. Now the issue with this is, since these classes contain pointers, we have to verify that object2 gets its own memory and it doesn't just copy the addresses in this object. Because then we run into problems when object1 goes out of scope and object2 is still in play. Object2 will still be using the memory from object1 and it gets messy. Now, an assignment operator, like I said, we won't cover it today, but just so you know what it looks like, we're going to have, say, a object2. Now, this one is called with the default constructor in this case. But then later in the code, we will say something like object2 is equal to object1. So this is the assignment operator. And notice that we're going to have some issues here. And it's almost exactly the same as this thing, in which we need to make sure that object2 will first deallocate any memory that it has, and then it will allocate some new memory in order to copy these properly. So we'll do this in the example. I'll just kind of show you what they look like. So rule of 3, the first thing we need is the destructor. That's number 1. The second thing we need is the copy constructor. And so what does this constructor take? It takes a dynamic array parameter. And sometimes we want to make sure that this remains constant so we don't mess with this thing at all. And we'll call it the copy. So it's going to take a constant object, the same type, and it's going to pass by address. We're going to say that this is constant because I don't want to change this in any way. And then the last thing we need is, I'm just going to put it here so you can see it, but we're not going to cover it until later. Okay, so that's number 2 here, and this is number 3. And we're just going to comment this one out because we don't know what that is. But I would like you to remember what the rule of 3 is. So now that we're here, we will code these. But before we start with that, has anyone heard the term shallow copy and deep copy before? And does anyone have any ideas? It's okay if you don't. But if you have any ideas, feel free to throw them out there. We're just going to consider assigning one variable or object to another. So let's just do a small example of that, right? So in your code, you might have something like int x equals 3, and then you might have something like int y, and then you'll have something like that says y is equal to x, right? Which copies 3 into y. So what about pointers? I'm going to ask for some class participation here. So let's say I've got 2 pointers here, x and y, for integers. I say x is equal to new int, right? Because I need to allocate the memory first. And then, if I want to assign something to this, like I did above, I have to say x dereferenced is equal to 3. So can anyone tell me what this does? We went over this last class. And did it do what I think it did? Meaning, well, that's kind of a bad question. Obviously, if I see out the dereference of y, it will spit out a 3, right? But did I copy the value of 3 or did I copy something else? I copied the address. Yeah, CBay's right. So I copied the address, right? This is an alias. And this is what we call a shallow copy. Exactly. So we alias them. Y now contains the exact same address that X is, which means they are the same thing. Aliasing is bad practice in general. Because whenever we change Y, we change X. Whenever we change X, we change Y. So that's what's called a shallow copy. And so here's what we'll do for that. We'll say here we've got a shallow copy, right? And what does that do? It looks like this. And then, can anyone guess now what a deep copy looks like? The deep copy is where we don't want to do this shallow copy, meaning we want Y to have its own copy of 3. So I'd probably say something like this, right? But there's one issue here. This will segfault, probably, because Y hasn't been allocated yet. So before we do anything, we have to say Y is equal to new int. And we dereference this to copy the value. Do you guys understand the difference between... Yes. Yeah. So red rose, yeah, you got it. The value in a new address. So, do you guys understand the difference between a shallow copy and a deep copy? When we shallow copy, we get memory leaks, we get aliases, we get dangling pointers. This is bad practice in general. And we're going to do even a Microsoft Paint diagram today, if I get the chance. So we've got the shallow copy and the deep copy. Is there anything else that I want to say about that? I don't think so. Well, let's talk about arrays. Let's do an array. So arrays are a little more involved. So in this case, right, MS Paint is the best. In this case, we allocate an array, right, and I'm assigning these values. And then I say something like int y. If I wanted to do a shallow copy of this, very easy, y equals x. Shallow copy always looks like that. A deep copy is a little more involved, where first we have to say y is equal to new int, same size, and then I have to go through one by one. Every time. Is this going to get obnoxious? Maybe. Are you going to do it a lot? Yes. Y located at I is equal to x located at I. Why does this work? Because we're dereferencing here, right? Remember that the brackets dereference. Remember that? These dereference. So in this case, we're doing a deep copy. We're not assigning anything. We're not assigning any addresses. We're assigning values. So that's the deep copy versus the shallow copy. And so now we're going to start coding up our class. Well, we've got some time here. We at least got through almost all of the notes that I want to. There's one more thing that we'll talk about, but let's just go ahead and get started on this. And that's really all I wanted to do. We're also going to have a few member functions for this array class. We're going to have a void insert, which will insert an int x into our array. We might do a delete later, but we'll at least do a print array function. And that's that, okay? So that's our dynamic array class. And let's go ahead and get started on defining some of these things. So let's do a default constructor first. Remember, if I want to access that constructor within the class, I have to use my namespace operator. So in here, let's say that array should probably be set to null pointer. We can even do it a better way, right? We can do it like this. And we can say size equals 0. And I'm not even going to do a body. It's just going to have kind of this empty body here because we're only initializing these values. Is my facing in the way here? It doesn't look like it. So now we're going to kind of get this idea of the shallow copy versus the deep copy. So I'll copy this. But this one is different, right? It takes an int size. Or we'll call it SZ. And we'll say it takes an int copy array, right? So we're going to copy whatever was in this array. This is an array, right? This is a pointer. And so you guys know, a lot of you, I guarantee, will do this. So I'll ask, is this okay? And I'll ask, is this okay? So if this is number 1, is this okay? I'm testing your knowledge. And this is number 2, is this okay? And we'll kind of look up here. We'll call size is just a regular int. And array is just a pointer here. So number 1 is fine, right? Yeah, Red Rose got it. Yeah, 1 yes, 2 no. Exactly. You guys are listening. I'm so proud. Exactly. Number 1 is fine. Number 2 is not fine. This is shallow copying. So what do we got to do? First thing we got to do is allocate new memory. So what we're going to say is array is equal to new int sz or size, either one. And then we got to copy one by one, right? Like I said, we're going to be doing this a lot. Int I equals 0. Then we're going to say I is less than size. And we're going to say I plus plus. And then we're going to say array located at I is equal to the copy located at I. And this is a deep copy. So now this constructor is okay, right? This constructor is okay. So we've handled that part. Let's come up here. We just did these two, right? Now let's start working on our rule of 3. Does anyone know what will go in this destructor? Take a guess. It's not complicated. It is not a trick question by any means. There's one line of code that will go in here, and I'm hoping that you guys can tell me what it is. And then we'll do the copy constructor as well. Whoops. Yeah, you guys are almost there, right? We're deleting, but we're going to delete the array, right? So if this array has memory in it, we're going to want to deallocate it. Otherwise, we get memory leaks, right? So the moment that this dynamic array comes into existence, yes, macros got it perfectly there, right? So all I'm going to type in here is this. It's not that complicated, right? And this ensures that when this dynamic array, where's my main? Call A or something. When this goes out of scope at the end of the program, the destructor will be called and it will automatically deallocate this value. It'll automatically deallocate this array. And Red Rose, I would say that's exactly one of the main reasons why there are destructors. Is whenever we're using dynamic memory allocation, we want to be able to use the array and ensure that we can properly deallocate it when the object is destroyed. So this is the main reason. And I know just a few weeks ago when we were talking about destructors, I was asking one of you guys to be careful with your use of the term deallocating memory, because we're not always deallocating memory when the destructor is called. In this case, though, we are. So now we're going to be deallocating that memory every time a destructor is called. So that's rule of 1, right? That's rule of 3, number 1. And this helps us prevent memory leaks. Now here's the copy constructor. Now I'll ask you this question. This is a constructor, and we're actually going to take these remaining 5 minutes to introduce our last little bit here. I just want to talk about this. So this is a keyword used in classes. It is a pointer pointing to the object that the member function was called with. My face is probably in the way here. So it is a pointer that's pointing to the object that the member function was called with. So it's a pointer, right? So we can do things like this. And we can do things like this. And in general, all non-static member functions and variables in the class are automatically accessed using this. So we've been using this entire time, except sometimes the compiler makes it easy on us. So notice here that we're working with 2 dynamic arrays, right? We're working with the one that's being constructed. Let's talk about in main here, right? And I'm going to ask you guys to help me here. So here I'm calling the copy constructor. Now, So just by looking at this statement and by looking at this constructor, can you tell me which object is the this object and which object is the copy object? So just by looking at this statement of B and A, which one is this and which one is copy? And recall that the constructor is being called from B. So when we check our notes here, I say that the member function was called from. This is B. Yeah, that's exactly right. So this is B, A is the copy. This refers to B, A is the copy. So here's where things get confusing, right? Because I'm going to say something like size is equal to copy.size, right? We may have experienced this a little. Excuse me. I'm drinking chai, and it's spicy. Spicy chai. So, we're referring to two different sizes here, right? And this dot size, or this size refers to B, and this one refers to A. We don't have to do this, but we will. And we'll actually use this in the assignment operator. And just to check addresses later on, for now, this is not necessary, but we need to know what this is referring to. So now, if we want to do a deep copy, we'll say this array is equal to new int size, right? If we want to ensure that we're referring to this size, we can do that. And just so people who are getting confused, this is the exact same thing as saying this. It's exactly the same thing. And then we're going to do a copy, right? So I'll just copy it over. Does that make sense? We're kind of running out of time here, so this is kind of where we'll stop. In next class, we'll pick up on the inserts and stuff. Assignment 4, you don't have to do any of this array stuff, so don't store it in your head too hard yet, you know what I mean? Don't study it too hard, because this is not in assignment 4. So we will come back to it, and there's no urgency to remember what we're talking about here, but today we should understand what the shallow copy and the deep copy looks like. Next class, I'll bring out my Microsoft Paint diagram. Next class, we won't go over the assignment, so we'll have some more time. And next class, I'll be sure I get my make files right so I don't look like a complete goober on stream all the time. So let me know if you have any questions on this kind of stuff. We're going to finish this code next class. So it's not done yet. We obviously have to do an insert function. And we have to go over how we resize arrays. But so far we covered the rule of 3 and stuff like that. So thanks for coming to the stream today. Thanks for bearing with me. It is Monday. Sometimes we have troubles on Monday. But it's the highlight of my day to see you guys all. I hope you're doing well. Ask me questions. I'm always up to help answer your questions. Please do your homework. Office hours are in 15 minutes. This code and these notes will go on Web Campus. And yeah, that's pretty much it. So have a good day, guys. Thanks for coming.